Good morning, friends. I have already discussed with you the first two concepts. I'm now going to discuss the third concept, which is fractions. What is a fraction? Fraction is a part of a whole or group. Fraction is a part of a whole or group. Let me explain fractions with the help of an example. For example, you have got a cake with you. You have got a whole cake is there with you. Now let me cut or shade little bit. I'll cut a small piece. This shaded part certainly a fraction, and we cannot able to write this in terms of numbers. This shaded part, it's very difficult to write in terms of numbers. On the other hand, suppose let me draw a circle and let me divide this cake into 4 equal parts. Then you can easily write the fractions in terms of numbers. Let me shade this. The earlier one, it's very difficult to write this part in terms of number, but here we can easily write this part in terms of numbers. So for that, you need to know how do you write a fraction. Fractions are the numerical value consist of two numbers written on top and bottom of a fractional bar. Fractions are numerical value written on numerical value consist of two numbers written on top and bottom of a bar, fractional bar. So fractions of the numerical value consist of two numbers written on top and bottom of a fractional bar. Here I told you already, this piece, this shaded part, it's very difficult to write in terms of numbers. This shaded part, it is very difficult to write as numbers. First of all, here this part, here it is easy to write as numbers, or easy to write in terms of numbers. The reason is, here the parts are equal. Here the whole is divided into equal parts. But here the same type of piece, if we can able to divide, then we can easily write this part in terms of numbers. Clear? So generally, if we divide the whole thing into equal parts, then it is easy for us to write in terms of numbers. In other words, we can easily compare that part with the whole thing. Here, how much this piece? We cannot compare it with the whole, but here we can compare it with the whole. Whole is divided into 4 parts. Out of that, one part is colored or shaded. Correct? So 1 parts are there, remaining 3 parts are not there. So we can easily write this as a number. I have already told you, written on top and bottom of a fractional bar. The number on the top is called numerator. The number on the top is called numerator. Which gives how many are there, how many equal parts are there. Equal parts are there with you. How many equal parts are there, or how many equal parts are shaded. How many equal parts are there with you. The number on the bottom, of a fractional bar is called the denominator. Which gives how many parts, equal parts, how many equal parts are there in a whole. Very important. In a whole is very, very important. So in one whole things, how many equal parts are there? That is called the denominator. Out of 4 parts, how many parts are taken, how many parts are shaded, how many parts that you have got is called the numerator. So this part can be written as a fraction by writing, two numbers. How many are there? Numerator. How many are there? How many are shaded? Only one part, one equal part. So we write 1 on the top. And totally how many parts are there? 1, 2, 3, 4 equal parts are there. So we can write this fraction as 1 by 4. Clear to you? So let me take one more example, then the things will be very clear. Let me take a rectangular cake. Let me divide this into number of equal parts. All the parts are equal. Now let me shade few parts. One here, maybe one here. Okay. How many equal parts are shaded? That is the numerator. So the numerator is, so this fraction is the shaded part. The shaded parts. How many are there? Shaded parts 1, 2, 3. Only 3 equal parts are shaded. Total parts. How many total parts are there? Total equal parts is equal to 1, 2, 3, 4, 5, 6, 7, 8 parts are there. So we can write this shaded part as a fraction. How do you write this shaded part as a fraction? So numerator is 3, write it on the top, and the denominator is 1, 2, 3, 4, 5, 6, 7, 8. So the fraction is 3 by 8. So out of 8 pieces, you have got 3 pieces. So we say that 3 upon 8 Okay, 3 by 8. Out of 8 parts, you have got 3 parts. Or out of 8, 3 parts are there. Totally there are 8 parts. There are different types of fractions are there. Let me move on to types of fractions. Types of fractions. First one is, there are many types are there. Unit fractions. Let me explain what is unit fraction. Unit fractions. Fractions, simple definition. Fractions whose numerator is 1. Just 1 are called unit fractions. Always one part. You divide a whole into any number of parts, just take one part. That fraction is called unit fractions. Second type is proper fraction. What is a proper fraction? A fraction whose numerator is less than the denominator. So a fraction whose numerator is less than the denominator is called a proper fraction. Next, third type is improper fraction. What is improper fraction? Numerator is greater. The symbol is greater symbol. Numerator is greater than denominator. This is a greater symbol. Bigger number is this side, smaller number is on the other side. It's open, it becomes very big. It's narrow, very small, like a dot. Little, very little. So the small number on the other side, a greater number is on the left hand side. This symbol is called greater than symbol, greater symbol, greater. If we put the other way, if we put this is a greater symbol, greater than symbol name is, this is less than. Okay, two symbols. Less than, greater than. Fourth one is mixed fraction. The word itself, the meaning is very clear. Mixed means whole things also will be there and some fractional part also will be there. So it is a combination of whole and plus fractional part plus proper fraction. Whole and proper fraction. So mixed fraction, whole and proper fraction. Okay. The next is very important concept, that is equivalent fractions. Equivalent fractions. It's a very important concept, equivalent fractions. Let me take one example to make this concept clear. Equivalent fraction. Let me start with an example. Let me take two biscuits, two whole biscuits. let me take 2 whole biscuits, same size, 2 whole biscuits I have taken. Out of that I am coloring just one. Okay. So it's a group. It is a group of things. Part of a group. More than one, it is a group. Out of that, this one is just a part of the group. Part of the group. So out of 2, 1. So how many colored? Shaded? 1. Whole thing is colored. Totally how many parts are there? How many whole things are there? Group? 1 by 2. So if you write it as a fraction, this is 1 by 2. So generally what happened? You will be getting snacks. 2 biscuits you will be getting in the evening snacks. Sometimes what happen? The biscuit packets, the biscuits in the packet are broken into pieces. Now suppose the same whole biscuits, same size biscuits, now broken into pieces, maybe broken like this, broken. Okay, so the shaded, you will be getting 1 out of 2 biscuits from the parts. Just you will be getting 1 biscuit out of these 2 for the evening snacks. Now what happened? 1 biscuit means you will be getting how many pieces you will be getting? The 1 biscuit is divided into 2 equal parts. So 1 biscuit is equivalent to 2 pieces. 1 biscuit is equivalent to 2 pieces. Another biscuits also we should divide equally, then only we can compare it. So here how many parts are there? 1, 2, 3, 4. Total parts. Denominator we have tried. Denominator is 4 pieces are there. Out of that, how many are shaded? How many are colored? Which is 2 pieces are colored. Now what you observe from this example? The quantity that you get is just 1 biscuit. Quantity is just 1 biscuit you will be getting. So 2 equal pieces together, it will be equal to 1 whole biscuits. So the quantity is same, but only thing is pieces are different. Here 1 piece, here there are 2 pieces are there. Okay, so in such fractions are called equivalent fractions. Quantities are same, but the number of pieces are different. Then we call such fractions as equivalent fractions. Equivalent fractions. So what are equivalent fractions? How do you get equivalent fractions? How do you get? Let me take the same example. 1 by 2 is that. How do you get 2 by 4? How do you get 2 by 4? We will divide 1 piece into 2 pieces, then the 2 pieces will become 4 pieces. So we will be using the idea of multiplying numerator and denominator by the same number. 1 piece becomes 2, divide 1 piece into 2 parts, then 2 piece will become 4. Clear? So we need to multiply both numerator and denominator by the same number, then we will get equivalent fractions. So how do you get equivalent fractions? Multiply numerator and denominator by the same number. You can multiply, at the same time you can divide a non-zero number. Okay, you can divide a non-zero number on both numerator and denominator, we will be getting equivalent fractions. Okay, so what are equivalent fractions? So fractions obtained by multiplying or dividing, a non-zero number, Fractions are obtained by multiplying or dividing a non-zero number, both numerator and denominator. Fractions obtained by multiplying or dividing both numerator and denominator by a non-zero number are called equivalent fractions. Okay, so we need to multiply both numerator and denominator by the same number, we will get equivalent fractions, or divide both numerator and denominator by the same number, we will get equivalent fractions. So one question is write 5 equivalent fractions of maybe 4 by let me give 4 by 6 solution. So equivalent fraction, only 5 equivalent fractions they asked. Let me first multiply these fractions. You can multiply both numerator and denominator by a non-zero number. Okay, so let me multiply 1. If you multiply, you will be getting same. 1 if you multiply, you will be getting same. So we want a different one, you multiply it by 2. So 2 4s are 8, 6 2s are 12. Second fraction, 4 by 6. Instead of multiplying, we can also divide. That is why I have taken 4 by 6. You can also divide by 2, same number. 4 divided by 2 is 2, 6 divided by 2 is 3. Another third one, 4 by 6, you can multiply 4 by 6, both numerator and denominator by 3, you will be getting 3 4s are 12, 3 6 are 18. Suppose fourth number, 4 by 6, you can multiply it by any number. I can multiply it by 100 also. 4 into 100 becomes 400, 6 into 100 becomes 600. Fifth one, 4 by 6, you can multiply it by any number. Multiply by any number. 9 table I write, multiplying by 9. 9 4s are 36, 9 6 are just testing your multiplication table, whether you know it correctly or not. So these are the equivalent fractions. So the 5 equivalent fractions of 4 by 6 are first 8 by 12 also equivalent, 2 by 3 is also equivalent, 12 by 18 also one and the same, 400 by 600 also same, 36 by 54 also same. So this is a very important concept. The same 4 by 6 is equivalent to 8 by 12, 2 by 3, only the pieces are more, quantity is same, but number of pieces are different. So equivalent fractions. Then next concept is reducing the fractions or writing the fraction in the simplest form. Writing the fraction in the simplest form. Lowest terms, simplest form. One example, for example, let me take 15 and divided by maybe the fraction is 15 by, let me take maybe 25. 15 by 25. This fraction is not in the simplest form. So what to do? To express this fraction in the lowest terms, simplest form, we need to reduce it to the simplest form. Reduce it. How do you reduce it? How do you reduce this bigger numbers into a smaller number? I have already told you the rules for equivalent fractions. You have to either multiply or divide a non-zero number, both numerator and denominator. Multiply, it will become a bigger number. So, if you want to reduce it, you should always divide. So, let me divide this by same number. Same number only we need to divide. So, for that, which number 15 is exactly divisible, 2 is not divisible, that 53 is possible, okay, 3 5s are 15, but 25 is not divisible by 3, so not possible. Then 4, not possible. 5, you try 5, what happens? How many 5s are there in 50? Yes, it is 3. How many 5s are there in 25? It is 5. Now further we cannot reduce it. So 3 by 5 is the simplest form of this fraction. Okay. Next, operations. We will move on to operations. I have already discussed with you the 4 basic fundamental operations: addition, subtraction, multiplication, division. The same operations that we will be performing on fractions. Addition of fractions. Addition of fractions. Let me take 2 fractions. Addition of 2 or more fractions. Addition of 2 fractions. The same rule, addition rule that I am going to use. It's a very, very useful, example that I have told you. Unless the quantities are equal, you cannot add. Okay. If here in fractions the parts are equal, then only we can add. If the parts are not equal, we cannot add. Clear? So let me take with one examples. For example, addition of fraction. Let me take one example. Add 1 by 2 and we'll take 3 by 4. Let me explain with this example. Half means, suppose a whole cake is there. It is a whole cake. Divide into 2 parts. Either way. Let me divide here. Out of 2 parts, 1 part is shaded. 1 parts are there with you. This blue color shaded part is there with you. Okay. Next, 3 by 4. 3 by 4. The same cake, same whole thing. Whole thing is same. But here the parts are different. How many are colored? 3 by 4 are colored. Small parts. Parts are very small. 2 parts colored, 3 parts are colored. Out of 2 parts, only 1 is colored, 1 is shaded. Out of 4, 3 parts are shaded. Now look at the parts in both the equal, things. Here the piece is very big. Here the pieces are small. So if the pieces are not equal, we cannot add. So we have to use the idea of equivalent fractions. Just now I have told you equivalent fractions. So we need to further divide this into same equal pieces. So for that, here it is 2 parts are there, here it is 4 parts are there. Okay. So those who know a little bit of mathematics, they will do this sum very quickly. Okay. So how do you divide equally? That's the question. how do you divide equally these pieces? Here in the small piece, big. Generally what happen, smaller we cannot combine, make it a big piece just by using Fevicol and all. It's the eatable one, we cannot apply Fevicols and all. So better the bigger one we can divide into smaller one. So the bigger piece we can cut into smaller pieces easily. So how do you cut? Whether you have to make one cut here or you have to make two cuts. So for that, in mathematics we have one more concept that we will discuss in the next lesson, LCM and HCF. LCM and HCF, that we will be discussing in the next lesson. So I will be using that idea, or without that also you can do it. So just I will make one cut here. Now the number of parts are equal. Number of parts are equal. Here I made just one cut here. What happened? In this cake also 4 parts, here also 4 parts. So now the parts are equal. Now the parts are equal. So we can combine it. Now if you combine it, how many parts will be there? 1, 2, 3, 4, 5. You can count also because parts are equal. So 1, 2, 3, 4, 5 parts are colored. 5 parts are colored. Clear? So if you combine this, if you combine these two things, put together, adding means put together, combine the parts, 1, 2, 3, 4, 5 pieces are there. So we write it on the top, numerator. Okay, how many pieces are there? How many equal parts are there? 1, 2, 3, 4, 5. That generally we write it on the top. And totally how many parts are there in a whole? Not both the whole together. In one single whole, how many equal parts are there? 1, 2, 3, 4. Only 4 parts are there. That will be the denominator. Okay. So once again, it's very important. Numerator is number of equal parts. 1, 2, 3, 4, 5. 5 parts are there. Numerator, no doubt at all. The denominator is number of equal parts in a whole. In a whole, how many parts are there? 1, 2, 3, 4 equal parts are there. So denominator is 4. So this fraction is a improper fraction. Numerator is more, denominator is less. So we call this fraction as a improper fraction. Okay. So this is with the diagram I have done it. How do you do it without diagrams? Let me explain. So first we need to write the first fraction, then the operation is addition plus you put between them, and the second fraction is 3 by 4. Okay, now the parts are not same, so we will be using the idea of equivalent fractions. Okay, so let me write this as multiplying by some number so that we can make same number in the denominator. Okay, so the next lesson we will be learning LCM and HCF. If we take LCM of these two numbers, we will get 4. In other words also, to bring same denominator, just multiply both numerator and denominator by 2, and the second fraction already 4 is there, so you don't need to multiply. So this is equal to 1 2s are 2 divided by 2 2s are 4 plus 3 by 4. Now what happened? Numerator is, denominator is same, so denominator no change. You see 4 equal things are there, so we should keep the same denominator and add only the numerator, that is the root. 2 plus 3. So the answer is 2 plus 3 is 5, and the denominator is how much? It's 4, 5 by 4. You see the answer here also 5 by 4, here also 5 by 4. Okay, so addition and subtraction almost same. So let me take one example for subtraction. Subtraction of fractions. Okay, so same like addition. Addition means put together, combine together. Subtraction is taking away. So unless the pieces are equal, we cannot take away the pieces. So equal pieces. Same idea. Let me take one example. Subtract, maybe let me take 1/4 from 5 by 6. 1/4 from 5 by 6. How do you do it? So from first we need to write you need to write 5 by 6. Then subtract, symbol is minus 1 by 4. Okay. Now it's little difficult to make same denominator we have to make. Once the denominators are same, then the parts are equal, so that we can add and we can subtract. So how do you make the equal denominators? For that, next chapter I told already, we will be finding LCM of 6 and 4. LCM of 6 and 4, we have a method is there that I will be telling you in the next lesson. 3 2s are, 2 2s are all are prime number. So we can stop here. 2 3s are 6, 6 2s are 12. We can easily make 12 pieces in the first whole thing, and also we can make 12 pieces in the second whole thing, so that the pieces are equal. For that we have to multiply. So 5 by 6 multiplied by 2, denominator will become 12 minus 1 by 4, we need to multiply by 4 other, we multiply by 3, same number only you have to multiply. So this will become 5 2s are 10, 6 2s are 12, minus 1 3s are 3, 4 3s are 12. Now 12 has come, the denominator. So which is equal to, come on, 12 is in the denominator, so p's are equal, same denominator, and we subtract only the numerator. 10 minus 3. What is 10 minus 3? 10 minus 3 is 7 by 12, the answer. Okay. So addition and subtractions are the very, very important concept in fractions. I think both are very clear to you. I can also tell you the rules. If you want to add two fractions, just look at the denominators. If the denominators are same, just add only the numerator and keep the same denominator. While adding two fractions, if the denominators are not same, then the parts are not equal. So first you have to make same denominator by dividing the pieces equally, then we can add or subtract the parts. The next operation is multiplication. Third operation is multiplication. Multiplication of fraction is very easy. Simple rule. Two fractions are there, you no need to look at the denominator, you no need to look at the numerator. Just multiply the numerator and multiply the denominators. Let me take with one example. Multiply, maybe or let me take find half of, simple example, I take find what is half of 3 by 4. Same example I take. Find what is, in other words, what is half of 3 by 4? What is half of 3 by 4? What is half of 3 by 4? Okay, first 3 by 4 is there with you. In that you need to take only half. Let me explain with one diagram. First 3 by 4, let me take a cake, a whole thing. I have to divide this into 4 parts. How many are colored? 3 parts are colored. 1, 2. So the colored pieces are there with you. Colored pieces are there with you. Now we need to take half of it. We need to take half of it. So we take half of it. What happens? Take half of it. So each piece I will take half. You take half of it. So I will color it with pink. Okay, half. Another piece you cut. In this also you take half of it. Third piece also you cut and take half of it. Okay. Now here the pieces are small, small, small. This also you have to divide. This also you have to divide into same number of pieces. Now the pieces are equal. Now the pieces are equal. Now the pink pieces are 1, 2, 3 double sided. Okay. Half of 3 by 4. Earlier 3 by 4. In that half only we want. Half is 1, 2, 3 pieces out of 1, 2, 3, 4, 5, 6, 7, 8 pieces. So this is equal to 3 by 8. 3 by 8. So how do you get? How do you get? Let me quickly draw once again. Once again let me explain because it's very important. So this is 4 pieces are there. Out of that 3 pieces are colored. 1, 2, 3 pieces are colored. This is 3 by 4. Now we need to take half of it. So once again let me draw this whole thing separately. Now I will, this is colored parts are there with you. These 3 parts are there with you. Now I am going to divide equally. Half I have to take. So I will color it once again this way. I will color it. From this also you cut. Half you have to take. Half you have to take. From this also you have to cut and take half of it. So how many are colored with pink? 3 out of, so this is 1, 2, 3, 3 out of 8 pieces. So this is actually 3 by 4. In that half I have taken. So how do you write that? For half of 3 by 4 is equal to 3 by 8. So half is one type of multiplication, you know, in symbol is into 3 by 4 which is equal to 3 by 8. So just observe this example. How do you get 3? Just multiply 1 into 3, 3. How do you get 8 there? Just 2 into 4, 8. So the simple rule, multiplication rule is multiply the numerator and multiply. For example, 1 by 2 into 3 by 4 is equal to 1 into 3 divided by 2 into 4. 1 3 is 3, 2 4 is 8. So it becomes a rule. This is the rule we use for multiplying to fractions. Very easy. Then the fourth concept is, fourth operation is division. Division of fractions. So how do you divide two fractions? Just already I told you, division is just opposite of multiplications. So if you want to divide one fractions by another fractions, you need to multiply the first fraction with the reciprocal of the second fraction. Okay, for example, divide, maybe let me take 3 by 4 by maybe some 5 by 7. Okay, divide 3 by 4 by 5 by 7. How do you do it? How do you do it? So simple rule says that first fraction, this is divided by first fraction divided by second fraction 5 by 7. The simple rule says 3 by 4 you write as it is, and the division you convert into multiplication. See, multiplication is the opposite of division. So what is the opposite of this number? We call it as reciprocal of this fraction. Reciprocal. So reciprocal means change the numerator into denominator, denominator into numerator. Okay, reciprocal. So change numerator as denominator, denominator as numerator. That's all. So division rule, first fraction as it is you should write, and the second fraction you need to reverse it and multiply it. That is the rule. So 3 into 7, 3 7s are 21, 4 5s are 20. The answer is 20 by 21 by 20. So what is the rule for multiplication and what is the rule for division? While multiplying two fractions, just multiply the numerator and multiply the denominator separately, and at last write it in the simplest form. While dividing two fractions, multiply the first fractions with the reciprocal of the second fraction. It is very important. First fraction as it is, you should write, and the second fraction we have to multiply it. Okay, so dividend, divisor. Dividend as it is. Dividend, no change at all. Dividend you should write as it is. Only the divisor you need to change. Numerator and denominator, denominator and numerator, and multiply using the multiplication rule. I hope you have understood the concept of fractions and the four basic operations on them, and I will continue the next topic in the next video. Thank you all.